So the next step is still working with compound inequalities, but now we're going to add in those negatives. Because remember, when we're dealing with negatives with inequalities, sometimes we have to flip our signs. So we have to remember that rule though. When do we flip our sign and when don't we? Remember, the final step is if we multiply or divide by a negative number, then we're going to have to flip those inequality signs. And remember, the trick to see that is if the coefficient is a negative. An easier way to maybe remember is if the best friend is a negative. So we still have a compound inequality. There's two inequality signs. We still have that variable in the middle. But now as we look at this, that best friend right there is a negative. And when we have a negative best friend, it means we have to flip the inequality signs. So instead of being less than, for my final answer, I'm going to have to flip those inequality signs and it's going to become greater. So for me, I like to do that first before I do any other work so that I don't forget for that very last step. So now let's go ahead and solve. We're going to keep that best friend, the negative 3 and the x, we're going to keep them together. So I have to get rid of that negative 2. Well, the inverse of a negative 2, a minus 2, we have to add 2. And remember, with compound inequalities, what you do to one side, you have to do to all of the sides. So don't forget all the way over there on the left. So 10 plus 2, I end up getting 12, is less than, I have negative 3x in the middle, negative 2 plus 2 cancels out, and less than or equal to 19, 20, 21. But now I still have that negative 3 touching the x. And remember, touching means multiply. So to get rid of multiplying by a negative 3, I can't just divide by 3 because only the 3's would cancel out. I also need the negative to cancel out. So I'm not just going to divide by 3, I actually have to divide by negative 3. And what I do to one side, I have to do the same exact thing to all sides. So since I'm dividing by a negative, that's when my signs are going to flip. So 12 divided by negative 3 is negative 4, is going to be greater than x, which is greater than or equal to 21 divided by negative 3 is negative 7. Now remember, if we cover up what's in the middle, it has to be true. So if I forgot to flip my signs, I would be saying negative 4 was less than negative 7. But remember, when we're dealing with negatives, the further negative you are, it's actually a smaller number. So negative 7 is actually less than negative 4. So because I flipped those signs, when I cover this up, negative 4 is greater than negative 7. That is actually true. So now I can go ahead and graph this inequality. And I need to include all the numbers from negative 7 all the way to negative 4. But remember, I want to include one more to the left and one more to the right. So I'm actually going to start with negative 8, then negative 7, negative 6, negative 5, negative 4. But remember, we're going to go one more, so I'm going to take it all the way to negative 3. The arrows in both directions tell me numbers are going to keep going on that number line. So I need circles at negative 4 and negative 7. And one of them is a closed circle. It's not just the one on the right. It's actually the one that's with negative 7. So x can equal negative 7. So that's the one I'm going to fill in because it's negative 7 is included in our answer. But over here, it cannot equal negative 4, so I'm going to leave that one open. And remember, I did tell you if you cover this up and it makes it true, x is in the middle of those two numbers. So we would shade everything in the middle. It actually makes sense if you split it into 2 as well. This is saying x is greater than negative 7. So from negative 7, I should be going to the right. But this one is saying x is less than negative 4. So from negative 4, I should be going to the left. And they join together in between. So this is is the one that a lot of people get mixed up on, and they think they should flip the sign because they see negatives. But remember, it's only if your final step is multiplying or dividing, or if your best friend is a negative. In our case right here, the best friend is positive. And if the best friend is positive, we actually don't flip the sign. It will stay true all the way throughout. So I'm just going to bring those signs down for my final answer. And now I can just solve it like a regular inequality. The 5 and the x are going to stay together, so I have to get rid of this 2. If there's no sign in front of the 2, then that really means that 2 is a positive. And to get rid of a positive 2, I have to subtract 2. And what I do to one side, I have to do to all sides. Over here, same sign, add and keep, I get negative 15 is less than or equal to, I have a 5x in the middle, and over here, same sign, add and keep, I get a negative 5. For my final step, I have to get rid of that multiplying 5, so I have to divide 5 on all sides. Negative 15 divided by 5 is negative 3, which is less than or equal to that x, which is less than negative 1. Remember, if I were to cover up what's in the center, it still has to be true. So negative 3 is less than negative 1. Because it's further to the left on the number line, that's actually true. So on my number line, I don't start with negative 3. Remember, we always want to include one number further, so I'm going to start with negative 4, then negative 3, negative 2, negative 1, and I want to go one number further, so I'm going to end at 0. I put my circles on negative 1 and negative 3. Which one has a closed circle? The negative 3, because that has the line underneath, which means it can equal. If it can equal, it's included in our answer. And remember, if x is in the middle, and this is true, then x is any number shaded in the middle of those two numbers. So with compound and inequalities, when the variable's in the middle and the inequality is true, we shade everything in between.